looks a bit different, but again, we sub-milli-arc second per year precisions are reached here. Beware of the fact that due to the design of the telescope and the scanning and all that, there are correlated errors on different scales. Of course, the most prominent correlated errors will be on the field of view itself, but then between the field of views, which are 106.5 degrees apart, there can also be correlations. So if you work in clusters, say, and you want to improve the parallax estimate, you cannot really hope that the errors behave ideally and that you profit from a 1 over square root of n decrease in the errors. It's just a cautionary note. The formal errors for the TGAS catalog are much smaller than the errors that we publish. There's covariance matrices for these errors as well that will be published. So they have been inflated to something that the DPAC thinks they can stand for. This is based on sort of the full scheme of the data analysis that is, well, this is not the full scheme, but the most important scheme, which has a number of loops that have to be closed. For example, we have to correct the stellar positions for chromatic effects. So a blue star will end up in a slightly different place than a red star on the CCDs. There is charge transfer inefficiencies of the CCDs that have to be modeled and corrected. There is, of course, you have to know the position and the so-called attitude of the satellite very accurately. We have instruments on board to do that. That position and that rotation rate is constantly changed by micrometeorite hits and so-called microclanks, which is the adjustment of the satellite to a new equilibrium, so to speak. And some of these loops have not been properly closed. So that's why we can't reach the full accuracy of the astrometric solutions at present. But this will be done for the second data release. So, 14th of September, that's when DR1 gets the go, and everybody can download data from several servers. There will be many mirror sites around the world. And here I just list the surveys that are ongoing and that already have overlap with the TGAS catalog. And that's primarily RAVE with more than 100,000 stars and LAMOST with more than 100,000 stars. Runners-up are Apogee and Gaia, and Gaia ESO is probably not going to win this race. But it's a survey on an 8-meter telescope, so it's maybe not too surprising that not many stars are observed that are brighter than 11th magnitude or so. How do you access Gaia data? Well, there is a Gaia Archive that you can already access now in principle. It is currently fed with simulated data. And there's various query forms, simple form, and an SQL type form where you can enter your code. And the full data set will be also available in a data center near you. This Gaia Archive also has visualization tools that have interactive. It's an interactive web application with linked views. So if you click on a certain region, then you get the proper motions and the parallax error here for the very same view. So it's quite a nice set of tools for you to play with, which does not preclude you from just downloading the data and doing your own stuff, of course. What about future releases? Those are still a bit uncertain. So if you go to the webpage with the release scenarios, you will read the word potentially. So it means that we have an expectation, but we can't guarantee that at this stage. So the next data release is planned for the end of next year. It will probably contain the 5-parameter astrometry for, again, all sources, radial velocities for the brighter stars, not the BP-RP spectrophotometry per se, but the integrated BP and the integrated RP, which can be used as a first temperature indicator for the stars. And this is also what, of course, DPAC does itself, namely to derive the effective temperatures and the extinctions for these objects. DR3 then probably a year later, but could be slightly delayed. Radial velocities for all constant sources down to roughly 15th magnitude. Astrophysical parameters. So this is the first time that we really try to do the full set of astrophysical parameters that can be derived. The actual spectra will be released, binary orbits, solar system results, and so on and so forth. One exciting thing that will be decided later this year is a possible mission extension. The consumables on board will easily last us another 5 years, and this is not only to recover the nominal mission accuracy that suffered a little bit through issues discovered in flight, but even to make possible new exciting science. So, depending on this mission extension, the final catalog will either be presented in 2022 or as late as 2027. But I think we are pushing hard for these data releases to get you into the game. I hope I whetted your appetite for Gaia data. Here's the menu. Of course, this is the final catalog menu, so I hope you're hungry, and I hope you go for it and you dig it. Thank you very much.
Thank you. We have time for lots of questions. So, are there any?
There's one.
See, yeah. Okay.
Could you tell me the magnitude range which you provide abundance information?
The magnitude range.
Yeah.
So abundance is, it's a little bit uncertain now, and it depends on. I mean, you will see the calcium triplet lines obviously down to 15th magnitude. That's what the radial velocity information is based on. So you can, as long as you see a line, you can infer a calcium abundance, I guess, with large errors. What our hope is that we can get abundances of more than just calcium down to 11th or 12th magnitude. So the data set will be of order 10 or maybe 20 million stars that will have stellar parameters, spectroscopic stellar parameters, and individual abundances.
How about the bright end?
Oh yeah, that's an open issue in some sense. It's a huge dynamic range if you talk 0's magnitude to 22nd magnitude. There is a gating scheme in place for the brighter magnitudes, and one hopes to, with a lot of tweaking, be able to even do the brighter stars. But I think at present, nobody makes a promise for the brightest 1,000 stars or so. So maybe we start at 5th magnitude, maybe we go to 2nd magnitude, something like that.
There are going to be lots of questions after DR1.
Oh, sure.
Okay. Any other questions? So, yes.
Andy. Andy was first.
Okay, go ahead.
I was just going to ask for DR1. How big is the file? Do you know essentially how big the file size is going to be if you have a covariance matrix for all of these and for all of the positions as well? I'm just wondering in terms of then multiplying that by how many people are going to be downloading it.
I've not seen a number, but that's of course why the data is going to be mirrored on all continents essentially. Not all, but the most relevant ones, I guess, so that you don't have to download the whole data set. It is probably quite sizable. It's certainly a few terabytes, but I don't know how big. I've not seen numbers of that.
Yeah.
Hans, yeah.
So my question is, I mean, with such a vast amount of data, probably it's also important to have some ideas how to inform everyone. I mean, of course you can download it. It's also a question, is there, for example, any plans for a Gaia conference where all this is presented?
Well, we're holding, of course, lots of meetings. We have been holding lots of meetings already since 2003, I would say. Yes, there are lots of Gaia meetings planned. Let me think. The next one, there's people here in the room that are organizing some, I'm sure. There is one in Potsdam in June of next year. There is one in Nice in April of next year, if I'm not mistaken. So there is conferences with Gaia in the title, and that guarantees that Gaia will be one of the main topics, yes. Plenty of meetings, I'm sure.
If not, let's thank Andreas again. Very nice talk.